Hello grade 12s. A good part of your revision for your exam papers is to go over past examples of exam papers. So today I'm going to be looking at the IEB 2018 final paper 2, which is the mechanical paper, and here are our topics: mechanical analytical for 20 marks, low-key for 40 marks, the isometric for 40 marks, and the mechanical assembly for 100 marks. Obviously you can see that your mechanical assembly counts half of this paper, so it's definitely an area that you would need to focus on. Specifically now I'm going to go over the mechanical analytical of this 2018 paper. The interesting thing about this 2018 paper, in particular the mechanical analytical, is they have used the same components that they do in the mechanical assembly as your mechanical analytical question. So that's just an interesting bar note. So let's get started. They've given us our title block. Here is the information of who it was drawn by, checked by, approved by, when it was drawn, and who signed it off. Always be very wary of if there's any writing in these blocks that doesn't relate to that. So all unspecified radii are radii 3, and we know that in mechanical drawings we have rounds and fillets, which could be included in that. Tolerances are plus minus 0.25, and that's who did this drawing, FJC Engineering. You'll note that the 2018 paper, the format is slightly, should we call it old school, where they were still what I would refer to as a comprehension. You'd look at the drawing and answer the questions. The more modern version has been a multiple choice. So please just be aware of that as we go forward. This is a slightly older format, where in the current format they are asking the mechanical analytical in a multiple choice format. Going through question 1, what scale is indicated by the drawing? So I'm going to come down here to the title block, and it tells me there that the scale is 1 to 2. Let's print our answer neatly in pencil. How many parts make up the belt tensioner? Again, we're going to come down to our parts list, and let's add these up. 3, 5, 6, 7, 8, 9, 10, 12, 13. There are 13 parts. What material is used for the bearing? So again, we come down here. Here is the bearing, and it is made from steel. What should all unspecified radii be? Again, remember, whenever they give you any written information as text, chances are they will ask you something about that. What is the diameter of the balls of the bearing? So when we come to part D over here, the ball bearing, there is what the ball bearing would look like in a true section, not the convention, and it says there are 10 balls on a diameter 10. Sorry, there are 10 balls of diameter 10. So there's our answer. The diameter, let's put the symbol in, of 10. What is feature 1 on part A called? So if we look over here, there is this little part here. Now this print isn't great, but I think that is supposed to be in hidden detail. When I come and look here at the right view, I can see that little aspect, which would be where part G, the key, would fit in. So that part is a key way. What is feature 2 in part A? Here we go. There is that curved shape like that when we have two components, generally one in the vertical and one in the horizontal direction, and that would be a fillet. Remember, in mechanical components, they don't want to have sharp corners because you could obviously cut yourself if you have a sharp metal corner. And they put these there for safety reason as well. Name the type of sectioning. 3. So that is in the actual shape. So they've just rotated it in that space there, meaning it is a revolved section. Feature 4. So here is the straight edge on this gear tooth, and that is a chamfer when they've cut a triangle off the edge of the component. What type of hole is shown by feature 5 in part K? Let's find part K. Here's part K. Here's feature 5. And they ask what type of hole. This hole isn't going all the way through the shape. It doesn't have a double line to indicate there's a thread on it. So all this means is that it's a hole that isn't going through there, and because it doesn't go through, it's referred to as a blind hole. Number 11. So these double lines here is referring to symmetry. So instead of drawing the whole shape, they've drawn only part of it, and they're saying that shape would be mirrored along this line. It's a symmetry line. 12, very common question, and that is for the pitch circle diameter. We need to look at how many surfaces need to be machined. So we're looking for our machining symbol. There's our machining symbol. So there's 1, 2, 3, 4, 5, 6. Please be aware that this is not the same symbol. It's got a circle there, and that indicates that machining is not allowed. So this one has been thrown in to try and put you off. So we've got 2 there, 2 there, and 2 there, giving us a total of 6 surfaces that need to be machined. Name the type of sectioning at J, number 7. So here's this hatching here. For me, the giveaway sign is that the line over here is what I refer to as a wavy line. It's an irregular shape, and as soon as they've got anything like that, that is on a part section when it's showing a small amount of section. Now we need to calculate measurements, so it's important that you understand the different ratios and formula that you use for your nuts and bolts. So part 8, the dimension on I. So here is I, and we're looking for that value over there. Now they don't tell us any measurement here, so we're going to have to come back to the parts list. In the parts list, it tells us that I is an M16 nut. They are looking for the inside value, so work out your thread value. So if our M16, our thread value is where we divide that by 10, gives us 1.6. So we now need to subtract 1.6 off this edge, 1.6 off that edge, which gives us 3.2. And we are subtracting that from our 16. So 16 minus 3.2 gives us a measurement of 12.8. They want the overall length of the shaft, so the shaft is part C, here is part C. If we add all those measurements up, scared to just do a simple calculation to make sure it's right. So that gives me a measurement of 152. Which part prevents the shaft from turning in the frame? And that is going to be part G. Which is the key. The last question here. Draw a neat freehand welding symbol indicating a fillet weld all round. Welding symbols and machining symbols are something that you need to learn and spend a bit of time knowing what they're all about. So a welding symbol has a broken arrow as its shape. So there's my arrow, it's broken over there, and it has a tail on this side. So that's the basic welding symbol, because this is indicating where you must weld. Over here they would tell you what type of welding it would do, or you would be doing. So a fillet weld is a triangle, an isosceles triangle, so this should be a 45-degree angle. And the symbol for weld all round is a circle at the break in my arrow. So there is the weld all round symbol, there's my fillet weld symbol. And that is question 1 of the 2018 IEB final paper. Time-wise, you should be taking more than 20 minutes to complete this. So please always stick to your time limits carefully. So this should be done quite easily in 20 minutes.